Welcome to another episode on the White Dog Garage YouTube channel. My name is Bob, and in this episode we're going to make some shelves for this tooling cabinet. This is my tooling cabinet. I keep things in here such as the marking out tools that I have, drills, taps, dies, tooling for the lathe, tooling for the mill, and various other accessories. It's a very nice little unit, didn't cost me a lot of money. I really like the idea that it has a flat surface on top where I can get out some tooling and assemble it in its holder, etc. However, this shop is a small shop, and whilst everything has a place and there's a place for everything, it can get a little crowded at times. And I've ended up in moving things around with the spare chuck, in this case it's the 4-jaw, but it could be the 3-jaw, and this indexing head along with the indexing head accessories, all sitting up here, somewhere to go. Every time I go to use the cabinet, they're in the way, they're a nuisance, and I want to do something about it. And what I'm going to do is fit a series of shelves on this side of the tooling trolley and move these items onto the shelves. As I often do in making things for use in this workshop, I've raided my offcuts pile for materials to make the shelves. I will be making 3 shelves out of steel to go on the end of the tooling trolley. The shelf frames will be made from 30mm or approximately 1 1/4 inch square hollow section. Steel angle will form the mounts which will attach them to the corners of the cabinet. Unfortunately, the offcuts bin did not have the amount of angle that I needed in all the same size, so I'm using 40 by 40mm or about 1.5 by 1.5 inch angle for one set of mounts, and 25 by 25mm or approximately 1 inch by 1 inch angle for the remaining 2 shelves. One of the pieces of 40 by 40mm angle has a chewed out end, having been used as a test piece for a plasma cutter that I repaired. I can feel a design feature coming on to deal with that. What I'm going to do is cut the damaged end out at an angle. I will then do the same angle cut on the bottom end of each mounting bracket. This is a simple design feature which will solve a bit of ugliness in the one piece and which will not affect the structure of the resulting shelf mounts. If you have been following this channel for a while now, you'll know that I recently acquired a welding table, which I modified for use here in the workshop. The joy of a welding table like this, with its accurately spaced fixing holes, is that I can quickly use some insert stops to position the shelf frames for welding together. With the 4 members of the shelf frame clamped in position and a quick check that the diagonals are the same, I'm ready to start welding. I'm welding the frames together using MIG with 0.9mm or 35 thou flux core wire. I start by tacking the frames together in the fixture and off camera finished welding them out. Once I had the shelf frames all welded out, I turned my attention to drilling holes in the mounting brackets through which the bolts will go to attach the shelves to the cabinet. Each bracket will have 3 holes drilled in one side of the angle, each one 6.5mm or about 1/4 of an inch in diameter. Having cut the bottom of each bracket at an angle, each one will now have a left and right side, which means the holes in one bracket must be on the opposite side to those in the other one for each pair. I've only shown the drilling of the holes in one pair of brackets here, the other 2 being drilled off camera. Okay, so how I'm going to set these shelves up is I'm going to use some pieces of angle and they're going to bolt to the side of the cabinet. The problem I've got is how to set it up to fix the shelf in place. Now I could clamp the angle brackets in place and weld it here, but I'll end up scorching the paint. So what I need to do is recreate this edge of the cabinet on the weld table, on the fixture table. And that's what I'm going to show you now. So what I've done is I have set up 2 pieces of 50 by 50 rolled hollow section. That's roughly 2 inches by 2 inches. If you've been a long-term viewer of the channel, then you may have seen these pieces before. They were a mistake that I made many episodes ago. I had to remake them, and I originally threw these in the scrap metal bin, and then I was in need of how to create this fixture. I could have brought in some lengths of steel from the steel rack, but I thought no. I saw these sitting there, I grabbed them out because they're the right size and nothing else. So what I've done is the cabinet itself is 457mm wide. I've set these at, and they're perfectly parallel, at 460mm edge to edge. And that'll give me 1mm or 2 clearance when I fit the brackets to the cabinet. So what I've done is, as I say, they're parallel, they're 460mm wide, and I put a bracket on here, a bracket on there. There is a line here, and this line is square, and I mount the frame for the shelf across the 2 brackets. I clamp that in place with this clamp, and then I can tack it together and it all comes out perfect for the job. And this is what the shelf unit looks like set up in the jig, which I then tack together. Off camera I've cut 2 supports which run between the edge of the shelf and the bottom of the mounting bracket, and I also tack these in place. With the first frame tacked together, I just do a quick test fit on the cabinet. Off camera, I've tacked together the other two frames, welded all three out, and they are now ready for paint and will be painted the same colour as the cabinet. Off camera, I have also cut out 3 pieces of 6mm thick structural ply that I will use for the shelf tops. I am attaching the shelf tops to the frames with blind rivets and start by pre-drilling the holes for the rivets to go into. I only do a few rivets at a time as I have to move the clamps and because the compressed rivets slightly distort the wood top, which will cause a misalignment of the distant holes. Notice also that I'm not fitting rivets in the exact corners. This is because the corners of the shelf frame were welded on the miter joint. The underneath of the weld can be uneven, which will cause hole enlargement as the drill pushes through, and can also prevent the blind rivet fully gripping the underside. Once I have all the rivets fitted, I use mineral turpentine on a rag to wipe off the pencil marks used to mark their positions. We're ready to start fitting the shelves now. I've put the cabinet on its side, make it easier to set it all up, get it all square. I'm at the stage where I need to select my fastener. The metal in this cabinet is 1mm thick, which is about a 32nd of an inch, or about 20 gauge. So I could use blind rivets, and that would work. Everything we're going to show you would work. This is what's known in Australia as a tech screw. The technical name for this particular one is it's a 12G by 20 hex head galvanised metal screw. We pride ourselves on being in a metric country here, but 12G is an imperial measurement. It's 12 gauge, not like a shotgun though. And the 20mm is the thread length. So if you're in America, it's 12G by 3/4 of an inch. What I don't like about these fellas is that you can over screw them in, overdo it, and strip them out. If you ever need to take them out, yeah, you can get them in and out a few times, but that's about the limit of it. The other thing is, because this is going to have a fair bit of weight on it, I want a fair bit of strength. What I'm going to go with is a fixture called nut rivets. Now, I don't think I've really featured them on an episode before. Now, nut rivets have probably been featured elsewhere on YouTube. I'm not going to go into great detail, but I will give you a bit of a demo as to how a nut rivet works. I am demonstrating nut rivet installation using this piece of sheet metal. I have already pre-drilled it with an 8mm diameter hole into which the rivet will go. The thread in the rivet size that I am using is M6, that is, it has a thread diameter of 6mm and a thread pitch of 1mm. Nut rivets are similar but different to blind rivets. Instead of the blind rivet's built-in mandrel, a threaded rod in the rivet pliers acts as the mandrel in the nut rivet. It is screwed into the threaded section of the rivet hat, and when the pliers arms are clamped together, the threaded rod pulls the nut section up, compressing the underside of the hat against the sheet metal to fix the rivet in place. The rivet can then be fitted with the chosen M6 threaded fastener, like the screw I'm using here to check the fit up. Nut rivets, sometimes called rib nuts or nut certs, are a great boon to sheet metal work. They enable a captive nut to be easily fitted, more so when access to the back of the panel is neither possible nor convenient. I've clamped the top shelf in position and I'm using a transfer punch to mark the positions for the screws. I'm just marking with a marker where the positions are. It's always hard to see these later on because determine whether it's really the transfer punch or just a dent. With the holes positions marked, I drill the holes for the first 3 nut rivets. Followed by a quick vacuum to pick up the swarf made by the drill. Then it is on to inserting the 3 nut rivets. Followed by, having turned the cabinet over, repeating the process on the other side. I am attaching the shelves with M6 pan head screws, which I get started using a number 2 Phillips head screwdriver. I then screw them home using an impact driver. Off camera, I've installed the nut rivets for the remaining 2 shelves and fitted all the screws. And now use the impact driver to do them all up. All that remains is to repack the cabinet. I like this modification. It gives me easy access to the alternative lathe chuck and the dividing head. What is more, I've also got the top of the cabinet back as a work surface with a bigger area now with the top shelf. That brings us to the end of this video. Thanks for watching. I look forward to you joining me for the next video from the White Dog Garage YouTube channel. Bye!